Hi, it's Paul Andersen, and welcome to Disciplinary Core Idea PS3D. This is on energy and chemical processes in everyday life. To really understand energy, you need to understand how it can be converted from one form to another. So where is the energy in this motorcycle coming from? Where was it before it was in the motorcycle, and where does it go when it's done? And so I was on ExxonMobil's website the other day, and they had a whole section on producing energy. And that's not really true. They're not really producing energy. Likewise, I was on PBS's website, and they had a video series entitled Using Energy. And that's not really correct either. Both of them are really talking about converting energy, because energy can't be created nor destroyed. It can be converted from one form to another. And so we really need to understand how that works. And so where's my energy coming from? Where's the energy of my thinking and moving and talking and all of that? Where's the energy come from? Well, it comes from my food. I like to eat granola for breakfast. And where's the energy in granola come from? Well, granola is rolled oats and honey. Where's the energy coming from there? Well, the oats are getting their energy through photosynthesis. What about the honey? Well, honey comes from bees, which come from clover, which is another plant. And so where's the real energy coming from? It's coming from the sun through this process of photosynthesis. And so I'm just simply converting the energy, and when I'm done with it, a lot of it's eventually going to end up as heat. Likewise with that motorcycle, where is its energy coming from? It comes from its gasoline. But where'd the energy sit before that? It was in crude oil. And before that, where's oil and fossil fuels get their energy? Well, they're built over millions and millions of years from ancient rainforests that were covered up in soil. And so we're back to plants again, and we're therefore back to the sun again. And so really what's happening is we're simply converting that energy into another form. And all energy eventually is going to end up in a real low-ordered energy called heat. And so when we're thinking about power generation, making energy for us to use or converting energy for us to use, there's many different forms. From coal to oil, natural gas, nuclear, solar, wind, geothermal, hydropower, there's lots of ways that we can make our energy. Now, some of these are what are called fossil fuels. I would put coal, oil, and natural gas with that. What does that mean? They've been produced over millions of years from ancient organic material. Some of these are more sustainable, like wind, solar, geothermal, but you should know this, that all forms of electricity generation and transportation have certain costs and benefits, be it economic, social, and environmental. And so it's hard to say this is what energy form we should use, because there are going to be benefits and drawbacks on all of these. Clearly, we would like to convert to more sustainable forms of energy, but right now we're stuck with a lot of fossil fuels. And so what we really have to do is come up with efficient designs. And what does that mean? The energy into a system is going to be used to do work, but a lot of it is going to be lost through heat. And so the less amount of energy that we can lose to heat, the more efficient that system can be. And so when you're designing something like an airplane, or a jet plane, you want to make sure that it's as efficient as it can be. We want it to be really, really light and aerodynamic, so it's not going to lose energy due to frictional loss. And so how do we teach this in schools? Well, starting with our lower elementary grades, we want them to understand that friction generates heat. If you ever have two objects that are in contact and moving around in relation to each other, it generates a little bit of heat. And so we need to know that we can reduce the amount of heat that's being produced. And so putting oil on a chain on your bicycle, it means that you're going to lose less energy due to frictional loss. And it's actually going to be easier for you to ride that bicycle. As we move into the upper elementary grades, we want to start talking about this idea of energy conversion and staying away from energy use or energy production. We're simply converting it from one form to another. And so where does food get its energy? Again, it originally came from plants. Where does gasoline energy get its energy? It gets it from fossil fuels, so it used to be forces. And even the energy that's stored in a dam, well, how did the water get above the dam? It was the water cycle, and it was heating of the sun that caused that energy to move up, or the water to move up and store that energy right there. We also want to talk about energy and making sure it's in the right area. And so batteries are wonderful because they can make energy available to us. And if we can increase the amount of efficiency of our batteries, we can do better work. Likewise, moving energy from one location to another is really difficult. We can generate it in a solar wind farm, but how do we get it to your house? How do we get it to my computer right now? We need to make systems that are as efficient as possible. As you move into middle school, you want to talk about photosynthesis and respiration. You really want to talk about it in general terms. You don't have to go through the steps of that. But how does photosynthesis work? We're taking energy from the sun, converting carbon dioxide and water into sugars and oxygen. So that oxygen is given off in photosynthesis. Likewise, how do we convert that energy? Well, we're going to take in that sugar and oxygen using respiration, converting that to carbon dioxide and water. We can generate energy there. And so most of my energy right now is coming from cellular respiration. All my energy right now is coming from cellular respiration. We also want them to understand the importance of design. And through proper design, we can increase the efficiency of a system or a machine for that matter and make sure that we're using as much of that energy as possible. Finally, as we get into high school, we want to understand that that energy coming from the sun is energy that's being produced through nuclear fusion. And so it's a fusion reactor. Now, it's millions of miles away, but it's producing energy that we can use. Plants have figured this out over years using photosynthesis. They can harvest that energy, and we're learning that as well. So using simple solar cells, we can harvest energy from the sun and use that. And so in the future, we're going to try to convert from more fossil fuels to more sustainable energy. And where's a great place to get a lot of that energy from? It's the sun. But it all depends on efficient design so we can harvest as much of that energy we can before it's converted to heat. And I hope that was helpful.